In this last section, we'll deal with fractions and radical expressions. So the rules of simplifying say that you cannot have a radicand, or the inside of a radical, that's a fraction. So if you do, we're going to use the quotient property to simplify. In other words, the square root of a over b is equal to the square root of a over the square root of b. Now, in some cases, that denominator is going to work out to be a whole number. In some cases, it won't. If the denominator of the fraction is not an integer, we're going to multiply that numerator and denominator by a clever form of 1 to do what's called rationalize the denominator. So let's take a look at that in practice. In example 1, the square root of 9 over 49, we have a fraction under the radical, so we're going to use the quotient property to rewrite it as the square root of 9 over the square root of 49, which is 3 over 7. And then we're done because our denominator is a whole number. All right, let's check out b. The square root of 5 over 36 is the square root of 5 over the square root of 36. And the square root of 5 doesn't simplify, but the square root of 36 is 6. Now, since our denominator is already a whole number, we don't need to worry about doing anything further with that one. It's okay for the numerator to have a radical in it. The denominator has to simplify to a whole number, though. All right, let's check out c. 4 over the square root of 5. Well, this fraction has a radical in the denominator. So what we're going to do is we're going to multiply that square root of 5 times itself, or we're going to multiply by the square root of 5 over the square root of 5. That gives us 4 times the square root of 5 over the square root of 25. Now, just in case you're wondering, that square root of 5 over the square root of 5 is what we call our clever form of 1. Any number over itself is 1, and so we're not really changing the value, we're just changing the way this fraction looks. So in the numerator, we have 4 times the square root of 5. In the denominator, the square root of 25 is a whole number of 5. So you see, by multiplying a radical times itself in the denominator, you rationalize it or get that to be a whole number. All right, let's take a look at d, the square root of 3 over the square root of 7. It's the denominator that we want to rationalize, so we're going to multiply by the square root of 7 over the square root of 7. In the numerator, the square root of 3 times the square root of 7 is the square root of 21. In the denominator, square root of 7 times the square root of 7 is the square root of 49. And the square root of 49 is 7. And that's our end result. We can't divide any further, even though 21 is divisible by 7. The square root of 21 is not divisible by 7. All right, try a below on your own. Simplified form for a should be the square root of 7 over 4. All right, now try b. Simplified form for this radical expression is the square root of 30 over 10. This one required multiplying by this clever form of 1 in order to get the numerator to be a whole number. All right, let's check out some more examples. And this time, these will have a little bit more difficulty, so maybe multiple steps. Square root of 2 over 5 is the square root of 2 over the square root of 5. And even though we use the quotient property, our denominator is not a whole number, so I'm going to multiply that by a clever form of 1 so as to not change its value. Square root of 2 times square root of 5 is square root of 10. And downstairs, the square root of 5 times the square root of 5 is the square root of 25, which gives us 5 in the denominator. Now our denominator is a whole number. All right, now let's do b. Square root of 1/10 is the square root of 1 over the square root of 10. And the square root of 1 is just 1. Square root of 10 doesn't simplify to a whole number, so we're going to multiply by this a clever form of 1, square root of 10 over the square root of 10. And in the numerator, we get 1 times the square root of 10 over the square root of 100. And a comment about the numerator, 1 times the square root of 10 is not fully simplified. When you multiply by 1, you get the same number. And then downstairs, or in the denominator, you get the square root of 100 is the whole number 10. So we get the square root of 10 over 10. All right, let's try one with an even harder difficulty level. or maybe it just looks more complex. It actually isn't that much more difficult. Now, in this one, you'll notice that we have 5 times the square root of 2 in the denominator. Now, the 5 isn't hurting anything. It's a whole number. But we want the denominator to be a whole number, so we're going to multiply by the square root of 2 over the square root of 2. Notice we don't multiply by the whole denominator. That's going to result in something that would need to be simplified a little bit more. All right, so in the numerator, square root of 3 times square root of 2 is square root of 6. And in the denominator, we have 5 times the square root of 4, which would be square root of 6 over 5 times 2 is square root of 6 over 10. All right, now let's try d. d, there's a radical in the denominator, so we're going to multiply by the square root of 3 over the square root of 3, our clever form of 1. In the numerator, they're not both radicals, both factors, so we're just going to multiply 7 times the square root of 3. And in the denominator, we have 2 times the square root of 9. So 7 times the square root of 3 over 2 times 3 is 7 times the square root of 3 over 6. All right, try A below on your own and pause the video while you do that one. All right, final answer on this one, square root of 21 over 7. All right, now let's try B, 6 over 5 times the square root of 7. Final result on this one of 6 times the square root of 7 over 35. And that's it for this section.